My name is Richard Taylor. I'm actually from North Carolina, here speaking today. I appreciate you spending your afternoon with me. And today I want to share with you actually using a couple of technologies to solve a pretty interesting problem. Actually, pretty common problem, but pretty interesting problem. So a little bit about myself. I'm a software engineer. I'm, as I said, based in North Carolina. I'm actually pretty active in the community, so I work with a couple of users groups. One of them, Modern Dev Charlotte, which is basically a group that's technology agnostic. We talk about all different types, front-end, back-end databases. And then I also lead the Charlotte Xamarin group, which is all about mobile development using the tool Xamarin from Microsoft. That's my website, my Twitter handle. I'm very active there. And then also, in my day job, I work on the platform and cloud engineering team. I actually lead that engineering team for a company called SentryOne. SentryOne, we're a software engineering firm. We build software for what's called the Microsoft Data Professional. So if you think about database developers, DBAs, those type, they use our software for performance monitoring as well as testing their SSIS packages, ETL jobs, database documentation, et cetera, that type stuff. So if you want to know more about that, that's our website, that's our Twitter handle, or you can talk to me later. All right, so I mentioned a problem earlier, pretty common problem. So let me describe the problem. Today, all of us, everyone here and elsewhere, are faced with just this deluge of information. Information coming from everywhere, all different directions. And it's very hard to keep up with. And so, here's a quote that I found on the internet about the internet, and just getting information from the internet. It's like drinking from a fire hose, right? We all struggle with that, right? And so, if you're like me, at the end of the day, my brain looks like this. I've got all this information. I don't know what's next, what's important, what's not. And so, what I decided to do was, being the software engineer that I am, is to come up with some interesting ways of trying to deal with that type of problem, right? And so, what I wanted to do was build this thing called a smart reader, okay? And the smart reader initially is going to focus on keeping up with RSS feeds, so blogs, news, that type of thing, online magazines. And it needed to be cross-platform. I wanted to be used wherever, on all of my devices. And I wanted to leverage cloud technology where it made sense, okay? And then I wanted to use machine learning to sort of help tailor the experience for me or for the end user to just make it a more personalized experience, all right? So the next question was, well, what tools or what tools should I use to actually accomplish this? And so I came up with this app called the Viewpoint Reader, and it's going to bring together actually several different technologies to actually accomplish this goal. So I'm gonna do a quick demo of the reader so you kind of get a concept of basically how it works, and then we can dig into the technologies and how it all kind of comes together. So let me switch over real quick to the reader. All right, so this is, it's not styled yet or anything like that. It's actually in development, so I'm gonna share with you the GitHub so that you can follow along and actually join in if you wanna play along with the whole process. And so this is a very simple app, but it actually has some powerful pieces to it. So first of all, think of an RSS reader. RSS feeds, you basically subscribe to them, right? You say, I want to get updates and things like that. But you also have to find them. You have to search for them. And so I have a subscribe tab or subscribe screen where you see a list of RSS feeds that I have previously subscribed to before we actually came here today. And you notice a lot of them are related to real estate investing, that type of thing. Actually, there's a real estate broker feed down at the bottom. And so for each one of these feeds, I can actually dig into them. I can click on it. I can look at the actual items that have been posts that have been published. I can click on them and actually go to the website and actually see the actual article itself if I wanted to. And I can move between feeds, obviously. So there's different feed items there. And so that's generally the concept, right? I'm going to have this list of feeds that I've subscribed to. And eventually when the application matures, obviously we'll have some organization around it, maybe folders, topics, things like that. But this is sort of early. All right, so that being said, the other item is I need to search for feeds, right? What am I interested in? And so on the search tab, we have here, I have a very simple, text box with the search icon, and then I can type in. And let's just say, let's say for the sake of argument, we're going to type in Jacksonville, let's say housing. And I'll do a quick search. And there's a number of things happening in here. This is more than just a web search. We're actually doing the web search. We're actually parsing the data, looking at the content, and actually running it through a machine learning model or machine learning model, and then scoring those feeds, and then actually using that to actually sort and recommend. All right. So there's a lot going on. All right. So here's the results. Now, a couple things. You'll see in red the title, you see the description, and then you see this number. The number is actually the scoring that's coming out of the model that we've used machine learning for, okay? Now, we'll get into the details of how that all comes about, but basically, in this app, when it's finished, you wouldn't see the score, but this is for demonstration purposes only, but you'll see how things are getting ranked, right? So based upon what I've selected prior, what I've subscribed to before, it's actually ranking these potential blog posts and news articles based upon my preferences, okay? And of course, as I subscribe to more, it learns more, and it gets better over time, okay? So that's generally the concept, okay? Does that make sense? Does anybody have any questions about any of that so far? Okay, cool. All right, so let's switch back over to the presentation, and we'll start to dig into sort of how all this stuff came together. All right, so, and I'll demo it. It is cross-platform. I'll actually show it to you on the Android and on the iOS device towards the end. All right, so first tool, Xamarin. Does anybody know anything about Xamarin? Use Xamarin? Few people use Xamarin, a little bit. Okay, cool. All right. I'll take a few minutes to kind of get everybody up to speed, and then we'll kind of keep going after that. All right, so Xamarin was founded in 2011, but actually now Microsoft owns it, right? And it's an open source platform, and it's really designed to deliver cross-platform applications in a single code base, okay? That is DesignGo. Now, with any tool, if you don't follow like certain prescribed ways of doing things, you can kind of get off into, the wilderness and get lost, and it doesn't really add value, but that is the DesignGo, okay? All right, so what platforms can you target? Well, at its core, iOS, Android, and UWP, which actually covers all of the sub-devices and platforms in there from Microsoft, okay? You can also target some of these. So Mac OS, Tizen. Who's familiar with Tizen? Tizen operating system, basically owned and managed by Samsung. Devices, mobile devices, watches, things like that, appliances, that's what it's used for. And then there was a project a while back. I'm not quite sure where it is, but in terms of supporting WPF, but there was a standardization project around XAML, which is a key part of this, that was actually going to standardize XAML, which then we could leverage to do a WPF solution. And then there's also a way to actually use Xamarin to build actually a web experience, which is actually pretty cool. So this has grown over, I guess, the last several years. It continues to grow as people look at different platforms. But this is pretty much what you can target. So how does it work? The key components, C# is the language. Okay. There is a compiler. So Visual Studio, either on Windows or VS Studio on Mac. The Mono.NET framework, which is at the core. That gives you the access to the .NET framework from a cross-platform perspective, so you can run on Android, iOS, and things like that. And then Visual Studio for Windows Mac, as I said before. So those are the 4 key components of Xamarin and what it brings to the table. All right, so how do we share code? So I said before, that is one of the DesignGo. So there's basically 3 options. One of them is a shared project, which is still used but not heavily used. This was the original way of doing things. Essentially, shared projects, the way they work is basically you have all the code for all the platforms that you want to support in a single project, and then you use compiler directives to kind of like parse out things. If I'm on this OS, this is what you want to do versus something else. Not very sophisticated, but still works. Portable class libraries. If you've been around the .NET ecosystem for as long as I have, portable class libraries have been around for a while. Design goal there was to actually write code once and you can run it on multiple platforms. One of the major drawbacks with portable class libraries is the fact that as a developer, you were responsible for deciding which platforms you needed to support. So you as a developer had to understand basically the intersection of all the different platforms and where you could leverage the actual cross-platform goal. And so it put a lot of burden on the developer. And so this new thing, .NET Standard Libraries, well, actually not that new, but a newer option came out, .NET Standard Libraries, and the responsibility then was sort of reversed. So basically, as a developer, you just coded to a standard. You understood that, hey, all these platforms, if they support the standard, they support this API footprint. It was up to the framework supporters to actually make sure that things work. So just think of it as a responsibility being flipped. And .NET Standard Libraries, this is the recommended way of actually sharing your code. So everything you see here as far as shared code is .NET Standard 2.0 library, which is basically the latest and greatest as it relates to .NET Standard, okay? All right, so visually this is what it looks like. So you see, I'm only using here in this diagram iOS, UWP, and Android. And you'll see, starting from the bottom going up, shared C# app logic. So this is where all your business logic would be. You write it once, and you can use it on any of the platforms. Then you have shared C# user interface code, and we'll talk a little bit about how you handle that. But that's actually what you at least my recommendation, what you should at least strive for. And then of course you have this little sliver of code that is native to each one of the platforms, where you go in and you do things like, well, for certain platforms you want certain experiences, and maybe you want to override how something works, etc. My recommendation is avoid that at all costs unless you want to get into all of that. And then what happens is you start to lose the benefit of writing once and running everywhere. Because now you have to understand all of the different platforms. So you can think about it, you can think of it from a perspective of, let's say your shop is a .NET shop. You have a bunch of C# developers on your team. If you wanted to support multiple platforms, without this option, you'd have to actually have people who know everything about iOS, Android, and so forth and so on, to augment the development of your software on those platforms, right? Well, with Xamarin, if you stick to trying to minimize the platform-specific code, those same C# developers, with a little training, can actually write a lot of code and actually build some very valuable applications, actually using the platform. So that's a promise. That's how sharing code works. All right, so we talked about shared user interface code. So this is where it gets interesting. So there's this concept. Or I'm sorry, there's this tool frame or framework instead of tools called Xamarin Forms. Xamarin Forms is basically designed for you to build a shared UI and it actually ends up being a native UI for all of the platforms. But the way you accomplish it is you use a combination of C# and XAML. Okay, now. I won't get into all the details about the different components, but the way you think of it, you have screens, you have controls. Those controls, when you compile for each platform, they actually translate into the actual native control that's on the device. So if it's a button for each, let's say I'm dealing with a button, and it's part of my app, but when I build for each one of the platforms, that actually gets converted to the native button on each target. Okay, It's all native, and the concept is if you can build out the user interface once, now you're in a situation where you can use it, reuse it. Okay. Now there's one thing I do want to point out. The DesignGo with Xamarin Forms, minus a few options that have recently been added, is that as a developer, you can use the same code to create that UI, but it is a UI that is pretty much very familiar to the end user for that platform, right? So it adheres to the design guidelines for iOS versus Android versus UWP. All right, so, and you'll see the differences when I actually show the app running in different environments. That is a specific design goal, okay? As opposed to like Flutter, which is more, you have full control and you can make your app look exactly the same on all the different platforms, as an example. That's a huge debate. I think early on, most people wanted their apps to be as familiar and adhere to those guidelines for each platform, so the end user was very comfortable with using their apps. But lately, I've seen a swing where most companies now, oh, well, if it's running on that and running on this, I want it to look exactly the same, right? And there are ways to do that. So most recently with Xamarin, material has been added. So now you can use that design system and actually you start to see things look similar across the platforms, which is pretty cool. So there's some options there, but the initial DesignGo for Forms was, platform experience being pretty much the standard for each one of the platforms. All right, so one last thing, using forms. If you stick to trying to use shared code across the platforms, you can actually get close to 96% code reuse across all of them. Actually, at this point and where this app is, it's 100%, and I'll show you. All right, so that's what it looks like. All right, any questions on any of that before I move on? Okay, cool. All right, so recently, well, not recently, I guess within the last year, there's this new set of tools called Xamarin Essentials. And so what Xamarin Essentials brings to the table is what it actually solves the problem that we used to have, and it's still, in some instances still have, when it comes to bridging the differences across the platforms. So for instance, let's say I needed to save a file on the device. Well, where you save files on the device is different for each device. And so what we had to do was we actually had to abstract that away using one example, using an interface, and our shared code would write or at least code against that interface. And then when we implement, the implementation details of the interface will be an implementation for each platform. So we'd have to figure out, okay, for iOS, we need to write a file here. For Android, we write a file here. UWP, we do it here. And so, and in some cases that's still needed, but Xamarin Essentials, the team came along and actually built all this stuff for us so that basically we didn't have to do that, right? And actually it's pretty cool. The other cool thing about Xamarin Essentials is that when you build your app, it's designed to only include what you're using in the app. So there's quite a few different options and features in Xamarin Essentials, but let's just say I use one or two of them. Well, the end result when I build my app is the one and two will be included in that code base. It wouldn't be the entire library, okay? So what features? Well, there's a lot of them. So here I'm showing, what is that, 25 or so? Yeah, about 25. I think there are actually a few more as of the last couple weeks. And the idea is, for example, let's say connectivity being one of them, right? I need to know if my device is online or not, right? Well, the way you do that on each platform is different. Well, actually, I can write to the API for connectivity once, and it actually works on all those platforms. Does it make sense? Yeah, it's pretty cool. And as a matter of fact, Xamarin Essentials now, the template from Visual Studio actually defaults it in. So they assume that you're obviously going to use it, but you don't have to use it. So, so any questions on any of that? All right, cool. So that was Xamarin. And of course, there's a lot more to that, a lot more to Xamarin than that. But so the second tool was Azure, right? So Xamarin got me my cross-platform, multiple device problem solved. Now I needed to deal with a few other things. Well, Azure, I wanted to bring in the picture because we needed to use Azure App Service, and I'll explain that in a second, specifically for web apps. And then we needed to use Azure Cognitive Services, specifically for web search, okay? So I could have taken a route of writing my own code to do the entire, okay, here's the text that came in, go search the web, go figure it out, parse it, and do whatever, right? But Azure Cognitive Services actually has that, okay, built in. And we'll talk a little bit more about that in a second. And then from the Azure Apps, web apps perspective, this was an interesting scenario. So remember I mentioned machine learning and I mentioned ML.NET. Where early on, I was actually able to use ML.NET on the device, which was actually my design goal. I wanted to build my model and actually then use my model on each device. Well, that's actually not officially supported, okay? And it worked. It worked actually probably, what was that, March? Up until about March, and then it stopped working. Now, it is on the roadmap to actually work on your devices, but it's just not implemented yet. So I had to fall back to a different solution. And we'll talk about what that fallback is and how it all works. So these are the two components we're using in Azure, and we'll talk briefly about them. Oh, and one other thing I did forget to mention, Azure Cognitive Services. So there's another feature in Cognitive Services called key phrase extraction. And I'll explain the concept, and then you'll see how it works. So you can send actually a text stream to Azure Cognitive Services, and it will actually parse out, using machine learning, the key phrases of that, let's say, paragraph, right? And what I'm using it for is to help train my model to know what topics that I'm interested in, okay? And we'll talk more about that in a second. All right, so Azure App Service, what is that? Well, it's platform as a service offering from Azure. It is basically used to create web and mobile backends for any platform or device, okay? It can integrate with SaaS solutions as well as connect to your on-premises applications and automate business processes. And we'll talk about each one of those on the next slide. Apps that run on Azure App Service is fully managed by Microsoft. So you as a developer or your development team can focus on your app. As far as servers, memory, and all that stuff, that's their problem. You pay them for that, okay? So, key features, auto scaling. So if I'm a startup or I don't want to invest too much money, or we're just doing a proof of concept, I can start small, but I can configure the thing to grow as needed. And it can be based on CPU traffic, or CPU, it can be network traffic, things like that. The other cool thing is it has a staging environment. So if I had a CI/CD pipeline and I just wanted to run it through my pipeline and my build and deploy, I can deploy the staging environment, check things out, and I can actually swap my production for staging, all built in. Obviously, it supports continued deployment, as I just described. And then it also has virtual networking. And if I wanted to, I can actually have an isolated and dedicated environment. So by default, it's shared infrastructure. So you're running on a box with other stuff, other customers probably. But if you wanted to do a dedicated environment, you could and still benefit from the other key features. But I will say it's expensive. So why do we want to use it? Well, we want to use it because it supports multiple languages, which is cool. It also should fall right into your DevOps operation if you have one. It's globally scalable. It has connectors that can be used for popular SaaS platforms and on-premises assets or platforms like a database. So a good example in that. When this first came out, I was able to use what's called logic apps to build a complete workflow for an application, basically, without writing a single line of code. So I was able to monitor a database, look for a new record, respond to that record by notifying a manager that something was created, and actually sending like a welcome email to the person that signed up for the service, et cetera, without writing a line of code, which is pretty cool. And then also there's a bunch of templates that are already out there. So for instance, in a marketplace, so if there's like a certain app that I'm looking for, I can actually buy it. The app services will come install with the app, everything ready to go within, well, it depends on the setup. It's pretty complex. It can take minutes, hours, but basically it's point and click. And then of course it's integrated in Visual Studio. So for instance, if I had a web app that I was working on in Visual Studio, I can right-click deploy and push it right out to Azure App Services, which is cool. All right, so app services comes in a few types. One is web apps, which is for hosting websites and web applications, and the web app for containers, which is a new thing. Mobile apps is still out there, but we don't want to use that, and I'll explain why. So mobile apps is basically designed for mobile backend. So if I have a mobile app that I'm working on, and let's say I needed storage for it, I needed auth for it, I needed notifications for it, mobile apps will bring all solutions to the table for all of that, and you didn't have to actually stand all that stuff up. But that's actually going to be retired in favor of Visual Studio App Center, which is going to offer, or is offering, all of those same services. And then API apps, which was basically designed for doing RESTful APIs. That's actually been folded into web apps, so that's actually not official anymore. And then logic apps is what I described before, automating business processes. You can connect to databases. I connect to third-party services. I've done one with Twilio. I've sent email with SendGrid. So logic apps is something that's pretty interesting as well. All right, so Azure, that was app services. So Azure Cognitive Services, what is that all about? Well, that's designed to help developers build intelligent applications without having direct AI or machine learning skills or knowledge. So I'm not a data scientist. I will say that up front. I have a team of data scientists that are on my team. But it's actually pretty powerful to be able to use some of these services and use the work of others to do a lot of these things that we need to create these smart apps, right? Azure Cognitive Services is delivered via RESTful API as well as an SDK. So that essentially makes it platform independent, right? In this solution, we're using the SDK, but there's nothing preventing me from standing up an HTTP client, actually making the same calls and getting the responses back and parsing the JSON, right? Supports multiple conversational languages. So there's a huge section in Azure Cognitive Services that is around language and text. It not only supports English, but it also supports many other languages. So it's something interesting as well. Now, overall, it covers these main areas. You have vision, speech, language, search, decision, which basically is anomaly detection and content monetization. And then this new thing that actually just came out, which actually I might look to leverage, is the personalization feature, which is in preview. The concept there is if I'm a user and you're a user and we're similar, you might like the same things I like, right? So if the system can determine that we are similar, then it can personalize an experience or personalize our experiences to be something similar since we might like the same thing, which is actually pretty interesting. So that's Azure Cognitive Services in a nutshell. Now we're going to focus on a couple pieces, just web search and key phrases. So web search, essentially, as I said earlier, I didn't want to write all the code to actually do the search and interface with search engine and all that sort of stuff. So there's a nice, neat, clean SDK that I can basically send in a search phrase. It will go out. It uses Bing. It will go out, do the search, give me a collection of what's called web search results. That has certain attributes. I can actually process those as part of the search feature in the tool that we're going to demo, or we're demoing today. So I'm leveraging web search for that. Web search does have some subcomponents, so if I just want to do a general web search, I can do that. If I just want to search news, I can actually zero in on news, and there are other categories. So just think of it as sub-search engines of a broader search engine. So key phrase extraction, this is an interesting one. This one actually falls under the text portion or text section of Azure Cognitive Services. And key phrase extraction, as I described before, and I'll show you examples when we look at the data, you can actually, you send it a description or you send it just a block of text and it'll pull out the key phrases, the key topics. And it's all based on, machine learning. And so we're leveraging that as a starting point to building our internal model in our app. Okay. All right, so that is the second tool, Azure. Any questions on that? There's a ton of Azure. That was like, 30-second video. There's a gentleman on my team back at work. That's all he does is Azure, and there are like hundreds and hundreds of services that are out there that you can leverage. Okay. All right. So let's talk about ML.NET. So what is ML.NET? Well, it's a machine learning framework, and it is cross-platform. Okay. As I said before, it's cross-platform up to a point. It does not work on particularly Android. It did not work on that platform, but it does work on my UWP solution. It's not supported on the ARM processor architecture, but it is in the works. It's designed to allow developers to build custom learning models. So, what we mean by that? Well, we talked about Azure Cognitive Services and it having a lot of services that you can leverage. But obviously, you're just making RESTful service calls or you're using the SDK. Well, you don't have a lot of control over that, right? So maybe there's something specific to your problem that you're trying to solve and you need to do something custom, then this is where ML.NET comes into play. All right, so you can build custom learning models basically in these steps. You import the available data, you transform the data for training, and then you create, train, and test, and then use the model, which is actually pretty common, basically workflow when it comes to machine learning. Now, I will say this, obviously building, going custom, you sort of have to know what you're doing. You have to kind of dig into it and kind of understand the nuances of selecting features and things like that. Typically, data scientists kind of get involved in a lot of that stuff. So the way I know at work, the way it works is that we have a set of data scientists on my team that actually do all the R&D. And then once they're at a point they want to actually try to begin to productize something, then we will actually work with them to basically transfer that knowledge into something that's workable that we can actually build upon. And in our case, ML.NET is one of the options for us. Okay. All right. So it is extensible. It will allow you to use other libraries as listed, and that's for not only importing and exporting. And there's a lot of work that goes on that. That's ongoing every day. And then the current framework status right now is version 1.2, which was just recently updated. All right, so any questions on ML.NET? All right, so how does this thing work? Well, we'll start on the left-hand side. So the app is running on a device, and there is some local storage there. So we're using SQLite for our local storage. Part of the reason is the app can work offline if it needed to, in terms of like reading what's been cached and things like that. But also we're using it for a few other things that it relates to how it supports the app. All right, so devices then talk to Azure Cognitive Services for the web search. So you plug in text, it sends that off, gets the results. And then the results come back, and then we send the descriptions off, and we actually to Azure Cognitive Services, and we pull out the key phrases, and that gets actually stored in a local database. All right, so that's sort of step one. Well, actually, steps 1, 2, and 3. Then we move into, okay, so we have the the search results, which are basically blog posts and feeds. And oh, by the way, I didn't mention that that there's a step in between web search and the key phrase extraction. We have to determine whether or not we found feeds. So there's a process that happens in the background where it's actually parsing all of the information that came back. Is there a feed here? If so, let's go identify and gather all the appropriate information. And then we get to the key phrase extraction. Okay, so now we're at key phrase extraction. And now we're going to move into the machine learning phase. So originally the design was, okay, I've got this local database, I've got all these key phrases, I've got the blogs themselves or the RSS feeds themselves, and I can just build a model off that data right there, right? And so I started down that path with ML.NET, and then of course it stopped working. And so I had to come up with a backup plan. So the backup plan was, okay, well, we're going to incorporate Azure Web Apps. We're going to build basically a RESTful service. And what we're going to do is we're going to actually ship that data up to that service and use table storage to actually build out the let's just call it temporary storage or interim storage, to build out the records that we had captured. And then run that through ML.NET on the API, and then store the model in blob storage. Okay, does that make sense? All right. And then there's another basically endpoint on the service that you send it basically the description of the feed, and it actually it just returns a score. Right? So there's a processing piece where we're extending our model, and then there's I need a score for what I just saw, so I can actually surface that in the app. All right. So as I said, there's several different technologies that's going on there. So that's pretty much the system architecture, and then how it's stored, model built, model maintenance, and prediction. Also, speaking about maintenance, so. As I said earlier, this is sort of in development, so I'm kind of playing around with different options. Right now, we're actually updating the model every time you subscribe to something, okay? So theoretically, what that means is it's getting smarter as I subscribe to an item. There are other options. We can do it. We can update the model on startup, maybe. We can update the model on shutdown. There's all maybe it's every 5. I don't know. That's the whole thing about machine learning and trying to come up with solutions, is always this R&D piece that you just kind of have to keep playing around with until you find out what works. But we do have options there. So any questions on the system architecture? Okay. All right, so application architecture. So this is basically how the app works itself. As I said, local storage, that's where the subscribe feeds are. It reaches out. Uses web search and key phrase extraction, and then uses the API to basically as secondary storage for the subscribed feeds, also for recommending and updating the model and recommending feeds from the search results. So any questions there? Pretty simple. All right, so on GitHub, and I have a link to the actual repository itself, but there's also the issues. So if you want to know the current state and kind of what I'm working on and kind of where things are and what's in development, there's an issues section there. All right, so let's take a look at the code. Any questions while I'm switching over?
So you've been playing around with Azure Cognitive Services for a while. Do they have a mechanism, for example, if I wanted to measure the similarity, like the Descartes similarity between 2 strings? They have 2 strings, say I have 2 research papers.
Yeah.
I want to give you string A and string B.
Yeah.
And get a number between 0 and 1. Have you seen anything like that they do, or do you still have to write that old school?
I have not personally seen anything like that, but it seems like a pretty common.
It's like fuzzy wuzzy.
Yeah, it's kind of common problem though.
Like the Python fuzzy wuzzy library.
Yeah.
Just a question.
I haven't seen it, but maybe afterwards we can look and see if something's out there. There's a service called Similarity? Okay.
Thank you.
Okay, there you go. Cool, thanks. All right, so let's take a look at how the code's organized first. So, yikes. I zoomed in too far. All right, can everybody see that? All right, cool. All right, so give you a high-level overview of how it's organized. So personal preference for me, I usually create a targets folder for all of my platform-specific code. As you see, each one, Android, iOS, UWP in this example. I try to stay out of there as much as I can, but you know, there are requirements at some point. All right, so Viewpoint Reader, the I guess fourth project down. That's actually where the core of the application is. That's essentially when we get there, we're talking about a lot of the cross-platform aspects of Xamarin and how to use them. All right, and so one of the key things in Xamarin is sort of the design methodology, where you may be familiar with MVVM. That's a recommended way of actually designing your application. So you'll see familiar folders like view models and views. So view models represent basically the state of your UI. The views should be responsible for just the UI interaction and work and pass things on. And so if we dig into them, you'll see I have several view models here, as well as several views. And typically there's a one-to-one relationship between those. You have a view model and a view, and that's pretty much how it works. So we'll dig in just a little. We'll dig into the subscribed view. See if we can paint a picture here. And I'm gonna have to zoom out so we can see the code. Actually, what I want to show you is actually the XAML. All right, so as I said before, when using Xamarin Forms in particular, XAML is the preferred choice. Now, you can do everything in C# if you like, sort of like in the old days. You know, you had web forms and the code behind, same concept, right? And so what we see here, we see here a content page, right? So page is basically a screen, okay? And then we have what's called views, which think of controls, same concept. Just call them views because it's abstracted away from the actual controls from each one of the platforms. And in this case, we have a list view, all right? And a list view is basically a list of things that we want to display, okay? And then there's some, there's some setup and ceremony, but you also see an item there's called an attribute that says item source, and that's where we do bindings. We can actually bind a control to some other state, and actually the control will react to it. So in this case, I'm binding the list of things to a collection that's actually part of the view model. Okay, so and it's what's called an observable collection. So when the view model changes, the UI just actually reacts. Okay, very similar to WPF if you've done that type of work before. All right, so and you'll see feed subscriptions. That's the actual type that it's actually bound to. All right, and there's a couple other things. There's some event handlers like item tapped, how we want to align, and some caching things. And then there's this item here called an item template. So basically the way there's a couple things you can do. There's some default ways of displaying items in the list view, but also you can customize, and which is where most people go. They want to create their own template for each item in the collection, right? So now in this scenario, there's something interesting that I'm doing. I have what's called a resource dictionary, and inside the dictionary I have a couple of data templates, right? And essentially all I'm separating is the fact that sometimes I might have an image from a RSS feed or not. And so I wanted to make it nice and neat rather than being kind of jagged. So I have a template for each one of those conditions. And then what happens is I have a selector that decides, as the data is coming in, it says, oh, okay, this doesn't have an image, so I want to use this template. Oh, this one does, so I use this template. But then it lines up actually quite nicely, as you can see. You see here, there's an image for this one and not for that one. If I didn't do that work, then what would happen is there would be space at the beginning of that line, right? And so that is the sort of the front end of the UI. There is some code behind, very minimal. Really all we're handling here is the item tapped. So when you tap an item, it takes you to the detail screen where you see all the items, and then you can launch off into the web and see that sort of thing. And then let's take a look at the view model. So here's the corresponding view model. And you'll see essentially the way I approach these things, it's more of a preference than anything. But anything that I make public on a view model, that's actually there's some kind of binding or something to the UI. Otherwise, it's all implementation details for the view model. And you'll see this feed subscription. So you saw that binding to feed subscriptions. There's the observable collection for feed subscriptions. So anytime that guy changes, the UI will change. And then when this guy gets instantiated, you'll see this application is also using a repository pattern. So when the screen comes up, it says, hey, I need a list. Oh, okay, well, here's the repository you need to go get that list from. And then it actually goes and makes a request, gets the list, builds out the UI, and so forth and so on. Okay, so that's how that works. Let's see. I won't go through all the view model views because it's pretty much the same kind of interaction. So I'll move into some of the other areas.
Can you expand the load subscribe feeds?
Yeah, sure. In the view model here? Yeah. 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 All right. So that is a .NET Standard 2.0 project. So that allows me to use all of that code on all the different platforms that I want to target. Okay. Now, let's talk about cognitive services. So that was another piece of the solution, right? So you'll see there are on the right, you'll see the cognitive services project, and you'll see some unit tests and some integration tests and all that good stuff. The normal stuff that we do in our everyday jobs, professional developers. So let's take a quick look. So there are two components to cognitive services. Remember, I said web search and I said text and basically the key phrases. So let's take a quick look at web search. Again, we're talking about a .NET Standard library. So again, it's reusable. All right, so here's all the code that's written to handle doing a web search. Okay, so I'm using the SDK, and you'll see. Actually, let's see if I can use this. Yeah, cool. All right, you'll see here we have search async, and we give it a string, right? Now there's a bunch of parameters that we send in here, but basically this web search API client has a method called search async. We pass along that query along with a bunch of other things that I can play around with in the SDK, which is unnecessary for this solution, and it returns a collection of web search results. That's it. So it handles all the network connectivity, it handles basically talking to the search service, gives me results. That's really all I'm concerned with for this particular application.
How do you configure for transition between environments for the targets, for the IP targets?
Transition between environments?
Say you have a tested dev. So how does your
Okay, so this is
URL shift?
Yeah. So in this, well, it's not necessary in this case, but let's just say I needed to do something like that. Maybe. Yeah, I would either do a standard web config, or I would do some kind of dependency injection and inject that in at runtime. One or the others, right? Okay. All right. So that's all there is to it, right? So this is why you want to why you want to use some of these services, right? It's just a simple search, right? Okay. So now let's take a look at the text analysis client, and this is where we use all of our extracting key phrases. All right, so now in our process, remember we got a list, now we're gonna send the descriptions up, and we need the key phrases extracted so we can actually build our model on top of that. Now I've got some not so best practices, I just hadn't gotten to clean that stuff up, but we wouldn't have that in there, right? For the same thing we just talked about. But you see here, there's sort of this client aspect to it again. Now we have this text analytics client, and I'm passing in a key phrases async, and what it's going to do is give me a result, and the result is basically a collection of phrases that it actually used its machine learning models on Azure to actually parse out and then give you back some results, right? And all I'm doing with that is, and I'll show you an example. Here. So here's a good example. See the description? And then see the key phrases. And you can see I'm building a model off of this because there should have been at least some machine learning applied to picking out what's important in the description, right? So I'm leveraging services again for that. And that simplified that part. Again, this is the .NET Standard Library. And then we get to the RSS work. And this is where all the heavy lifting happens. So let's take the search workflow. Search workflow is this simple. This is the string coming from the user. This is me using the web search client to actually do the query. Now I added blog in there. I'm kind of playing around with this right now because I want to make sure that I'm getting news or blog feeds, something that might have an RSS feed. I might change this out and actually do something different, but that works for now. I'm processing everything, and I'm actually doing a lot of async work here, where we're getting the web results and I'm processing the results to actually get out the RSS feeds. And then when I see feeds that are active, I'm actually filling it into my final result down here, which this final result is the results that are actually sent up to the UI. So as I said before, there's a number of different stages that we're going through to actually get to that list, right? And I have to do some performance improvements there. But once we're done with search, we can go back up top and take a quick look at the search view model. And you'll see if I tap something, and actually it would be on the, I'll show you the complete picture here. If I tap something on a view, so this is a search view, here's the code behind, it's going to handle item tapped. And what it does, it calls save subscription on the view model, right? What that does is, comes over here, and it's going to kind of run through its process. It's going to save it locally. And this really depends on, well, actually going to save it locally here. It's going to actually save it to it's going to call the API and save it up there so we can actually update the model. And then there's a couple other things here where when the results are coming in, we actually use this view model actually to score the feed. So it's up there now. We're going to actually call the view model, call the API to actually get the score back, and it becomes part of the results that are actually displayed. All right, so all of this, so everything from here down is, except for this API, is .NET Standard 2.0. And then quickly, here's the API, and I'll just show you the controller real quick. And there's a couple actions on it. You'll see this actually gets, actually here, this actually saves the feed. This actually, when I want to update the model, I'll call build model and it runs through its process. And then when I need to score a feed, I actually send it in a subscription, it will run it against the model, score the feed, and send it back. And that was the very quick walkthrough of that. All right, so let me switch back over so I can show you.
Yeah, you're not in a hurry, man. I don't know why they're out there.
What's that?
You got a lot of time, dude. They're out there banging on the door and stuff.
Oh, yeah, exactly. All right, so the code, that's a repo where all the work's happening. If you want to know more about Xamarin, there's all the docs and recommendations, etc. For Azure, those are all the links for all the different services that we talked about. Again, mobile apps is is dying. We should be using Visual Studio App Center. And then everything you want to know about ML.NET, this first, here's the documentation, and then this is sort of an introduction to the program manager that's actually over the whole .NET program, ML.NET program. So that being said, are there any questions on any of this that I talked about? I know it was a lot, bringing a lot of different technologies together, but at least for me, it's a pretty interesting approach to solving a problem. Any questions? Yes, sir.
You said it worked before, and then it stopped working?
Yeah, ML.NET. Yeah, so it's not officially supported on the ARM architecture, so mobile devices. But when it was in development, so ML.NET's been around for a while. Let's just say it was internal to Microsoft for a number of things. A year ago, they started developing it in the open. It came out with version 0.1 about a year ago, maybe a year and a half ago now. And it was being developed in the public along the way with public contributions. And when I started this project back in January, it worked. I was like, okay, well, I'm going to try it anyway, just to see. And it was actually working. But it was always not supported. And at some point, there was a breaking change that caused it not to work.
Can you go back to 1.1?
I could, but there's some features. So some of the algorithms that I'm using for this solution are only available in the later version. So if I go back, I'd have to come up with something else in terms of scoring, right?
You use SK like process and just wrap it?
Yeah, that's some other option as well. I mean, there are options out there, so I just came up with an interim solution because it is on the roadmap to be supported. So I'll fall back to the device managing it. Now, the jury's out on whether or not that's the right choice, right? Because when you think about it, I mean, devices are powerful, but how much do you want them actually doing machine learning tasks and things like that?
Point, though, man, IoT frameworks, Raspberry.
Well,
it doesn't matter which one you pick.
Yeah.
All of the IoT cards are on.
Yeah, well, that's very true, right?
They're going to have to come back around.
Yeah, well, and they will, and that's sort of the thing. So this is sort of an interim solution, but it still demonstrates how to kind of bring all of the pieces together. And it's just, and the other cool thing too, remember I said it was .NET standard? Well, when I wrote that API, I didn't change any of the ML.NET code. I just referenced that same project from the API project, and it just worked.
It was 4.7.2 to 2.0?
No, it was 2.0 to 2. It was 2.0 to .NET Core 3.
Oh.
Yeah. But the point I'm making is that if you can do it in .NET Standard and you want to reuse it, that's what you want to try to do. So hopefully that answered your question. I mean, I don't know exactly why, but I could not. It would not allow me to build a model. So any other questions? Awesome. Well, I appreciate you sitting an hour with me and kind of learning about all this stuff. Have a wonderful rest of the conference. Thank you.